Good morning to all of you. In the previous lecture, we discussed about binomial distribution and expectation and variance of binomial distribution. And today, we are going to discuss about Poisson distribution. Poisson distribution is also a discrete probability distribution. And Poisson distribution can be derived as a limiting form of the binomial distribution under these three conditions. Number one is what? N. The number of independent binomial trials is very large, that is n tends to infinity. If n, and second one is P. The probability of success in each trial is very small, that is P tends to 0. And third one is NP equals to lambda, a finite number. We have already know that the probability mass function of binomial distribution is what? P of x equals to ncx p power x into q power n minus x. Here x takes the value 0, 1, 2, 3 up to n. Here notice that n is what? Number of cases, and p is the probability of success, and q is probability of failure. Remember that in case of binomial distribution, n is finite, but in case of Poisson distribution, n is infinite, and p, the probability is very small. And by using the definition of combination, we get this one will be ncx will be what? N factorial divided by x factorial into n minus x factorial. And see that we consider np equals to lambda. This implies what? P equals to lambda by n. And we know that P plus Q equals to 1. This implies what? Q equals to 1 minus P. Therefore, we write in place of P equals to lambda by n, and in place of Q, we write 1 minus lambda by n. And we just break this down. And after simplification, we get the probability, a mass function of binomial distribution like this way. P of x equals to x equals to what? N into n minus 1 into n minus 2 up to n into x minus 1 into lambda to the power x divided by x factorial into n to the power x into 1 minus lambda by n whole power n minus x. See that in case of Poisson distribution, n is very large, that is n tends to infinity. Therefore, to obtain the probability mass function of Poisson distribution, we must have to take limit as n tends to infinity in the probability mass function of binomial distribution. Therefore, we take limit as n tends to infinity in both sides of this one. Now, let me break each term. Now first we have to find the value of this term. Limit n tends to infinity, n into n minus 1 into n minus 2 and so on divided by n power x. And after simplification, we get this term will be what? This term will be 1. Again, we have to break this term also. And after breaking this term, limit n tends to infinity, 1 minus lambda by n whole power n minus x equals to what? This one equals to e to the power minus lambda. And putting the value of these two terms in the above equation, we get limit n tends to infinity, p of x equals to x is what? Lambda to the power x divided by x factorial into e to the power minus lambda. And this one is called a probability mass function of Poisson distribution. Here, notice that x equals to what? X equals to 0, 1, 2, 3 up to infinity. X may be infinite number. But in case of binomial distribution, we choose x equals to what? 0, 1, 2, 3 up to n. N is finite. And let me define Poisson distribution. A discrete random variable x is said to follow Poisson distribution if its probability mass function is given by p of x equals to x is what? E to the power minus lambda, lambda to the power x divided by x factorial, and x takes the value from 0, 1, 2, 3 up to infinity. And here lambda is called the parameter of this distribution. And Lambda is called the parameter of this distribution. For example, number of deaths by snake bites is an example of Poisson distribution. These are some examples of Poisson distribution. Let us take a problem. From a population consisting of defective and non-defective items, 100 items are drawn at random. Find the probability of getting 2 defective items, given that the population consists of 1% defective items. In this problem, we have to find the probability of getting 2 defective items. And here, n is what? N is 100. This is very large. And p is what? 1%. That means this one is 0.01. This is very small. Therefore, we use Poisson distribution. And in case of Poisson distribution, what we get? Lambda equals to what? Np. Therefore, lambda will be what? 1. And by the definition of Poisson distribution, we get P of x equals to x is what? E to the power minus lambda into lambda to the power x divided by x factorial. And here we consider x denotes the number of defective items. X denotes the number of defective items, and we have to find the probability of getting 2 defective items. Therefore, we can write x equals to 2 in this definition. And after putting the value of x equals to 2, we get this one will be 0.185. That is, the probability of getting 2 defective items is what? 0.185. Let us take another example. If x follows binomial distribution with probability mass function p x equals to x, 100 c x into 1 by 50 whole power x, 49 by 50 whole power 100 minus x. X takes the value 0, 1, 2, 3 up to 100. Find the approximate value of p 1 less equals to x less equals to 3. That means we have to find the approximate probability of 1 less equals to x less equals to 3. Here see that x, here n is what? N is 100. This is very large. And p is what? 1 by 50. This one is very small. So, to find the probability, we use Poisson distribution. Here lambda is what? Np, and lambda is Np. Therefore, after putting the value of n and p, we get lambda equals to 2. And from the definition of Poisson distribution, we get p of x equals to x is what? E to the power minus 2. That means e to the power minus lambda. Here lambda is 2. Therefore, we can write to the power minus 2 to the power x divided by x. And we have to find the value of p of 1 less equals to x less equals to 3. That means what? P of x equals to 1 plus p of x equals to 2 plus p of x equals to 3. Thus, put the value of x equals to 1, 2 and 3 in this definition, we get the required probability. And this one will be what? 0.388. Here we discuss only 2 problems. You may try to solve another problems related on Poisson distribution. Thank you.